All right, this is our extra inverse derivatives homework walkthrough. So just going to be using the inverse rule again. Remember that our inverse rule says that if f and g are inverses of each other, and f contains some point a comma b, we know that means g contains the point b comma a, then f prime of a is 1 over g prime of b. So that's the rule we're going to use. We're going to look at this first one. We have f of x is 2x plus 1 cubed. We know f and g are inverses, and we're given that f of 0 is 1, which means that we know f contains the point 0, 1, which means that g contains the point 1, comma 0. That's just a property of inverse functions, right? You flip all the x and the y values. So we want g prime of 1. So we should be able to see that g prime of 1, according to our rule, should be 1 over f prime of 0. Well, then we just need to figure out what f prime of 0 is. Right, so to find f prime of x, we're going to have to use the chain rule, right? Because f is equal to u cubed, where u is 2x plus 1. So that should be 3u squared times 2, or 6u squared. So 6 times 2x plus 1 squared. And then we want f prime of 0. So that should be 6 times 1 squared. Well, 6 times 1 squared should just be 6. And now that we know that g prime of 1 is 1 over f prime of 0, well, that's just 1 over 6. And that should be our final answer. For our second one here, we're again given that f and g are inverses, and we're given a point that's on f again. We have the point 0, 1 is on f, and g then must contain the point 1, 0. So in order to figure out what g prime of 1 is, g prime of 1 will equal 1 over f prime of 0. Well, then we just need to find f prime of 0. F of x is 2x plus e to the x, so f prime of x will just be 2 plus e to the x, giving us f prime of 0 equal to 2 plus e to the 0. E to the 0 is just 1, so we end up with 3 for f prime of 0, which means our final answer should just be 1 over 3. For this next one, we're given a nice chart here that g and f are inverses, and we want to find g prime of 4. Well, if we want g prime of 4, that means that g contains a point 4 something, and f contains a point something, comma 4. So if we look in our chart for the value of g of x when the value of g of x when x is 4, that's negative 2, which tells us that the value of f at negative 2 should be 4. And if we look in the chart, we can see that that is also true. So what this tells us then is that according to the inverse rule, g prime of 4 is equal to 1 over f prime of negative 2. So all we have to do is go in our chart, find f prime of negative 2, which is 4, and get an answer of 1 over 4. All right, we've got 2 more quick ones to do here. So we've got this function x cubed plus 4x plus 2, and we know that g, the inverse of f, has a point 2, comma 0, which means that f has a point 0, comma 2. If we're looking for g prime of 2, according to the inverse rule, ought to be 1 over f prime of 0. So we'll figure out what f prime is. Right? F prime of x is just 3x squared plus 4, according to the power rule. And then just evaluate that as 0. You get 4. And we can plug in f prime of 0 up here to get 1/4 as our final answer. And lastly here, we've got x cubed plus x squared plus x as our function. And f and g are inverses. we know that G contains this 0.3 comma 1, which means that F contains the reversed point 1 comma 3. And that if we're looking for G prime of 3, it should just be 1 over F prime of 1. So we just need to find F prime of x. Well, that's just power rule, 3x squared plus 2x plus 1. And then we'll evaluate it at 1, giving us 3 plus 2 plus 1, or 6. So we can take our F prime of 1, plug it in over here, and get an answer of 1/6. And that's it for our extra inverse derivatives homework walkthrough. Just use the inverse rule every time.